spreadsheet file and save it as a new version by using the same convention in V2 instead of V1. Label cell A21 statistics. B21 P100 and C21 P1000. In cells A22 through A25, enter your descriptive statistics, DS, labels. In A22, put mean, which is the average. In A23, put N, which is the sample size. In A24, put SD, which is standard deviation. And in A25, put SE, which is standard error. There are two methods of selecting data in Excel. You can either click and drag on the dataset, or you can type the first cell designator of the dataset, followed by a colon, followed by the last cell designator of the dataset. In B22, type for mean equals average B4 through B13, followed by a parenthesis. In B23, for sample size, enter equals count parentheses, select your data set, close parentheses, and hit enter. In B24, for standard deviation, enter equals STDEV parentheses, select your data set, close parentheses. To compute standard error, there is no built-in formula, so you'll have to enter it yourself. The formula for standard error is standard deviation divided by the square root of the sample size. In B25, for standard error, enter equals B24 divided by SQRT parentheses B23 close parentheses. Select cells B22 through B25 and drag the little box at the lower right corner of the highlighted area to the right to propagate the formulas into column C. This will calculate the descriptive statistics for your data in C4 through C13. Now convert your calculations to the appropriate number of significant figures. A good rule to use is the least number of significant figures within the calculation determines the number of significant figures in the answer. Make sure the final answer is not more accurate than the instrument with which you made the measurements. The lab manual explains some other rules for determining significant figures. In this case, we're going to leave N, or the sample size, as it is, and convert the other three statistics to 3 decimal places. Completed descriptive statistics for your data, we are going to complete a statistical analysis called a t-test. The lab manual explains what a t-test is and how to analyze the results. You may want to read the paragraph on page 22 in the lab manual before continuing. To enter the formula for a t-test, click on cell B30. Then go to the Formulas tab and click on this icon in the top left corner. A dialog box called Formula Builder will pop up on the right. Scroll down until you see t.test and double-click it. You can also search for it in the search bar. Looking at B30, the function appears. There are now 4 rows in the Formula Builder to enter information. To select your first data set, click on the Array 1 box in the Formula Builder, and then select the 10 numbers in the P100 dataset by clicking and dragging. You can also type B4 colon B13. To select your second dataset, click on the Array 2 box in the Formula Builder, and then select the 10 numbers in the P1000 dataset as you did for the P100 dataset. Again, you could also type C4 colon C13. Next, specify the number of tails. Click the Tails box in the Formula Builder. We're going to use a two-tailed t-test, Enter a value of 2. Finally, specify the type of t-test. Select the type box in the formula builder. You want a 2-sample test assuming unequal variance, which is a type 3. So type 3 in the type box and click Done. The p-value will be displayed in B30. Now, make sure that this displays only 3 decimal places. Make sure to label this cell as the p-value in your spreadsheet. You can now close the formula builder. The last step is to make sure that you highlight all formulas in your spreadsheet so they're easy to locate for your TAs and professors when they check your work.
After calculating the descriptive statistics, it's now time to graph your data. First, make sure descriptive statistics are labeled properly. Your tables should look something like this. We'll be graphing the mean mass measurements for the P100 and P1000 pipettes. In your descriptive statistics table, select the 2-column labels and the means for the P100 and P1000 by clicking and dragging the highlighted box around the appropriate cells. In this case, it's cells B21 and 22 and C21 and 22. Next, go to the Insert tab. Select the column icon and choose Clustered Column. We're using a column graph because the data are in discrete groups with no mathematical relationship. As you can see, a graph pops up in the worksheet. We'll want to move it to a separate sheet so that it's easier to work with. Click on the Move Chart icon. Select the New Sheet bubble and give the sheet a name. Then click OK. Now you can see the graph appears on a sheet of its own. Now that our data is displayed in a graph, we'll want to format the graph properly before putting it in our lab report. First, add axis labels by going to the Add Chart Element icon. Select Axis Titles and go to Primary Vertical. This will put a title on the y-axis. Go ahead and type in an appropriate title and make sure to include units in parentheses. The x-axis already has labels under the 2 columns, so we don't need to include an additional x-axis label on this graph. Next, remove the grid lines on the graph by clicking the Add Chart Element icon and going to Grid Lines. Uncheck any grid lines that have a check next to them. We'll also want to remove the title. Do this by simply clicking on the words and hitting Delete on the keyboard. Now we'll want to format our data appropriately. Double-click on one of the columns on the graph to bring up a Format Data Series window. On the left side, click on the Fill icon. Select Solid Fill and choose a dark solid color. In this case, the default blue works just fine. Next, select the main part of the graph by double-clicking on the white space around the columns. A Format Plot Area window will appear. Select Border and go to Solid Line. Then choose black for the color. You can't see it now, but Excel puts a default box around the whole graph and axis labels. We'll want to remove this box, so double-click the white area outside the axes. In the Format Chart area window, go to Border and select No Line. The next step is adding error bars to your data. Error bars represent standard error, and they're included in the graph to help the reader assess the variability of the data around the mean. Under the Chart Design tab, go to Add Chart Element and select Error Bars. Go to More Error Bar options. Under Error Amount, check Custom and click on Specify Value. Click on the icon at the right side of the positive error value bar. You can then go into the worksheet and select the cells containing the standard error numbers you calculated earlier. In this case, it's the numbers in cells B25 and C25. Click on the same icon for negative error value and select the same two cells as before. Then click OK. Now you'll see there are appropriately sized error bars on the graph. Our last step to formatting the graph will be to set the y-axis scale. Double-click on one of the numbers on the y-axis to set the scale a number of decimal places. Under the Format Axis window, click on the column icon. Try changing the minimum value while leaving the maximum value the same. See how this changes the look of the graph. Decide which options best display your data based on the results of your t-test and set the scale appropriately. In this case, 0.096 is a good value for the minimum, and 0.103 is a good value for the maximum. Once this is complete, our graph is now properly formatted and ready to be included in a lab report. You can refer to the lab manual for how to input the graph into Microsoft Word and how to write an appropriate figure caption.